there is just different ways that this can look. So this first part, we're going to put in the word altitude. So you don't really need to know these words, but an altitude is going from one vertice straight down, making a perpendicular degree angle. What this is doing is it's taking one big triangle and it's actually splitting it into two similar triangles. So in this one picture, there's three triangles. There's the big one, and then there's the little tiny one, and then there's this medium-sized one, okay? To set up a proportion whenever you have an altitude, we're going to be comparing two separate triangles. So if I say we're going to do the same thing as before, we're going to do the big divided by small thing. So this is the big one. This is the small one. So if I say for the big, I want to use BD, and I'm going to try to write like a little proportion. So BD, I need to find the corresponding part to BD on the smaller triangle. So BD is right in the middle. So what two letters corresponds with BD? FH. So FH is going to go on the small section, F to H. And then based on where your X is at or where your numbers are at, you're going to compare that to one of the sides on the big triangle. So I can use, I don't know, BA. BA is on the big triangle. What would BA be similar to on the small triangle? What two letters? FE, so this left side. We're going to do the same thing. You could write a proportion for this is technically an angle bisector. So angle bisector can go here. So we don't have that 90-degree angle anymore, but it is an angle that's splitting. So I can do the same thing. I could do big triangle divided by small triangle, big divided by small, where I'm comparing pieces. So if I say QS is on the big triangle, it's right in the middle. That is the angle bisector. What does QS correspond with on the smaller triangle? UW, perfect. So I can say UW has to go on the bottom. And then if I have the other side, because I need my fraction for the other side, because this is where I would cross multiply. And then I say that I have, I don't know, QR. What would QR on the small triangle correspond with? UV. So they have to have matching pieces. So it's just like what we were doing before. It just looks a little different. The last kind that they have, so there's an altitude, which makes 90-degree angles. There's an angle bisector, which is splitting the angle. This last one is called a median. The median is where it's the mid segment of the bottom or the base. So it's splitting that into two equal parts. So this piece is congruent to this piece. So same idea. I'm going to use the big triangle first. I'm going to compare it to the small triangle. So if I say HJ, what does HJ correspond with on the other triangle? LN, perfect, in the middle. And then I need, let's say I use HG. What would HG correspond with on the other triangle? LK. So it's literally just matching pieces. And then we're going to do the same math that we did last week where we cross multiply, making our butterfly, and then we solve for X. Okay, so let's start with number 4, just because people think number 4 looks weird because you got like a dashed line in there. So for number 4, this is technically an altitude because it's creating that 90-degree angle. Okay, but that doesn't really matter. What we're going to do is we're going to set up a proportion. So the idea is we're doing big triangle divided by small triangle, big triangle divided by small triangle. So I'm going to say big over S to start. And it's okay if you flip your fraction, if you do small divided by big, however you decide to set it up, it needs to match for the next equation. So something on the big triangle. So if I'm looking at the big, pick a number that's on the big triangle. It doesn't matter which one goes first. Sure. So 42, if I choose to use 42, what would 42 match with on the small triangle? X. So I have 42 over x because it's big triangle divided by its matching small triangle. On the other side, I still need big on top. So what's left for the big? 15. And I'm dividing by its matching small piece, which its matching small piece, 12. And then it's the same math as last week. I'm going to start by cross multiplying, making a butterfly, a beautiful little butterfly. So I'm going to go crisscross. I'm doing 42 times 12 is equal to crisscross the other way, 15 times x. So in a calculator, what is 42 times 12? Somebody with a calculator, because that's a lot. 504, okay. 504. 15 times x is just 15x. And then I have to solve for x, so I'm going to divide by 15 on both sides. So in a calculator, what do you end up getting? You get a decimal. .6. So that is my value of x. We're going to do the same thing. Let's set up number one. Number one, if you look at these problems, they only have two numbers on each triangle. It's like two numbers and two numbers and two numbers and two numbers. So the rest of them only have two numbers. So it's easy once you figure out the one, you have like the leftovers to match it with. Number one is a little bit different only because it gives you three numbers. So I do not have to use every single number. Okay. Yes. So just an FYI for number one, there's three numbers on each triangle. So I'm not going to use all the numbers. I am going to pick numbers to use. But it does matter which ones match with which ones. Okay. So let's start with setting up our fraction. Let's do big divided by small. And then I know I'm going to have a proportion. So I'm going to set up my little fractions to get me ready. And now we're going to look specifically at the big triangle. Let's say I choose to use 15 from the big triangle. 15, if I choose 15, what would 15 match with or correspond with on the smaller triangle? X. And now I get to pick if I want to use the bigger number or if I want to use the smaller number. It doesn't matter. So let's say I use, I don't know, 20 on the bigger triangle. You can look at this one of two ways. 20 is the smaller of the two numbers. So that's going to correspond with the smaller of the two numbers. You can also tell that these pieces correspond because 16 is obviously smaller, because DE is the first two letters of this similarity statement. So DE corresponds with ST. They're giving you this similarity statement for a reason. Some of you can use your eyes to see which pieces match, or you can use similarity statement, or you can think logically. 20 is the smaller number out of 24. So then 16 goes with 20, 19 would go with 24 because the smaller piece would have to go to the smaller piece, the larger piece would have to go to the larger piece. Or you could use similarity statement. So 20 over 16. And then I'm going to do the same thing. I'm going to cross multiply. So 15 times 16. And then 20 times x. So what is 15 times 16? 240 equals 20x. And then I'm going to divide. So what do you get? 12. Okay, the last two on the front are decimals. So just be aware whenever you're doing them, they're decimals. People freak out when they get a decimal, but they are decimals. Let's go to the back side. On the back, the top one on the back is just like the front. So you have a similarity statement, you have a big triangle and a small triangle. The last new thing is technically this triangle angle bisector theorem. It says that an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. And you're like, what the heck? Why is there words in math? Okay, so disregard that. Instead of having literally two separate triangles to compare, this is two triangles within one triangle. So you have a big one. We're going to call this one the big. And then we're going to call this one the small. Because using your eyes, one is big and one is small. Okay. And then we're going to set up a proportion comparing the sides to them. So if I say one way that you could do this, same thing, we're going to have big divided by small. I'm going to set up my little proportion part. If I say on the big triangle, AD first, what would AD correspond with on the smaller triangle? DC. So these pieces are similar, so they go together in one fraction. And then I can choose basically what I'm comparing. If I say B to A, because that's the big, so the big has to go up top. That's what the B stands for. If I say AB, what would have to go in the bottom? B to C. So instead of having two separate triangles, it's just combining the triangles in a different way. Same thing though, we're going to set up proportion, then we're going to cross multiply like a butterfly. So let's do number 10. So number 10, we're going to set up our proportion. We're going to compare the big triangle to the small triangle. So down here, I have two triangles. This one's my big, this one's my small. So I'm going to do big over small. I'm going to set up my little fraction bar. What is one number that's on the big triangle? What'd you say? Oh, you're on a different question. So on number 10, 27. So 27 right here. It's on the big triangle. On the smaller triangle, that's going to match this piece right here. This piece is not 45. What would this length be if the whole distance is 45 and this piece is 27? What is this piece going to be? 18. So sometimes you're going to have to use subtraction to figure out that missing piece because the whole distance is 45. 27 plus 45 or 27 plus 18 makes 45. So big divided by small. Now, what would have to go in the numerator of the second fraction? What's left on the big triangle? 3x minus 9. And what does that correspond with on the smaller triangle? X plus 11. So when you're cross multiplying for this one, you're going to have to distribute. So we'll set it up and then I'll give you a second to try to solve it. So we're doing 27 multiplied by x plus 11. You will have to use the distributive property. And then we're going to go the opposite direction, butterfly. 18 times 3x minus 9. So take a second, try to distribute, see if you can solve this, and then we'll go over it in a second. Okay, so If you have solved this all the way, what do you get? You should get x equals 17. If you did not get that, I'm going to go over it. If you got 17, then feel free to move on through the rest of the problems if you want to start on the front, but I'm going to go over this one. Okay, so you should get 17. So I'm going to distribute to get rid of the parentheses, which is multiplication. 27 times x is 27x. And then 27 times 11, because you're multiplying, you should get 297. So plus 297 equals, and then I also have to distribute on the other side. Anytime there's parentheses, you got to distribute to multiply to get rid of them. 18 times 3x, multiplying is 54x. 18 times 9 is negative 162. And at this point, you can solve this technically 4 different ways and get the same answer. You can either, to start, I like to move the numbers first. So you can either minus 297 to both sides, or you can add 162 to both sides. Literally does not matter. You're going to get the same answer. Okay. So let's add just to get rid of the negative. So I'm going to add 162 to both sides. If you subtract 297 to both sides, you're going to get the same exact answer. So 297 plus 162 gets you 459. And then I have to minus 27x to both sides. So if I subtract 27x, you would get 459 equals 27x. And if you did it the opposite way, you would get the same type of numbers. You would just have negatives. Your negatives will cancel out in the end, though. So you would get negative 27 and negative 459. They would just be switched. So then if I divide by 27 to both sides, that should give you x equals 17. So for all of these, you're looking at your 2 triangles that you have, and you're setting up a proportion. Big divided by small. There's like 8 different ways to set these up. So it's, if you mess up, you might like just mess it up and it might be correct because there's 8 different ways to set these up. If you want to set them up and then let me check them before you start going, that's totally cool. That's fine. I'm going to tell you which ones are decimals, just so that way you have a